Hey there, meteorologist Ian Kelly here. When was the last time you checked the radar? For some of you it may be just a few minutes ago, for others this morning, and for a few of you I know you've probably never checked the radar. You've just left it up to the guy on TV because all these blobs and colors don't make any sense to you. Today I'm going to dive into the basics of how radar works, how that data gets to your phone, and how to read it. Even if you know how to read basic radar, I'm going to teach you in depth on how velocity, correlation coefficient, and reflectivity radar all works. Let's dive right into it. First things first, let's talk about how radar works. Radar stands for radio detection and ranging. Essentially, radar systems send out pulses of radio waves from the top of a tower, and when those waves hit something like raindrops, hail, or even flocks of birds, they come bouncing back, almost like a bat's echolocation. Now, the radar isn't just sending these signals in a straight line, they're sending them at angles, or tilts as they're called. These help create a 3D picture of the sky so that meteorologists can identify not just where the precipitation is, but what kind of precipitation it is and how intense it is. But who's behind these radar signals? Well, mostly it's the National Weather Service with their network of towers across the country. These towers are constantly collecting data 24/7, but major airports also have radar systems to help manage flight paths and overcome adverse weather conditions. Here's a map of the radar coverage in the US. As you can see, the West Coast is a little bit less covered because there's not as much need and there's not as much population density as the eastern side of the country. So, you've got all this data being collected from thousands of different radar signals bouncing around the atmosphere. How does it get from those towers to your phone or your TV? Let's take a look. Once the data is collected by the NWS or airport radar towers, it's processed and then distributed. But it doesn't go directly to your devices. It first goes to various commercial weather companies like AccuWeather, the Weather Channel, your local news station, WeatherBug, pretty much everybody. These companies take the raw data, format it, and integrate it into their platforms. For the TV people, it might just be they get it on their green screen with all their fancy little doodads. They add their own graphics, sometimes overlaying traffic maps, lightning, severe weather alerts, then push it out to you via their apps, websites, or TV broadcasts. So now you know how this data makes it to your phone and to your TV. But how do you make sense of all of these colors and blobs? Well, let's break down how to read radar. Okay, so you've got your radar app open. What do you see? Most likely there's some blues, some greens, yellow, orange, red, moving across a map. Let's decode how this works. On a basic radar reflectivity map, blue and green usually mean mist to light rain, dark green to yellow and orange shows moderate rain, red or pink can indicate hail or sometimes even tornado debris coming up from the ground. Then there are warning polygons if you're in a severe area. These would show up as trapezoids or just polygons in general to show you where storm danger is. Let's take a look at a classic radar example. The Moore EF5 2013 tornado. Do you notice that hook-like shape on it? That is a classic sign of a supercell producing a tornado, but we'll get to that in a different video. As you can see, you see a lot of red and orange on that map, meaning there's a lot of heavy rain falling. You can even see some of the warning polygons. I want to draw your attention to the little ball at the bottom of the hook. See how it's got red, white, and pink? That is because there is significant amounts of debris being launched in the air from that tornado. That is pieces of that city being lifted up into the atmosphere. There might also be some hail there because that's where a hail core typically is on a storm like that, but mostly it is debris like pieces of houses, pieces of trees, flying up into the atmosphere. Reflectivity isn't the only radar product you use. There's also velocity, which shows the movement of particles in the atmosphere. This is great for notating how fast a storm is moving. For example, you see this. This is a fast-moving storm, as you can tell by the brighter colors. Green means it's moving towards the radar. Red means it's moving away from the radar. It's great for also spotting rotation in a storm, like a tornado with a velocity couplet that indicates rotation. As you can see, the two colors are mixing and are together, which indicates that there is air rotating at that level. It's a big red flag for tornado formation. Another important radar product is correlation coefficient, or CC for short. This one helps detect debris being lifted into the air by a tornado. A lower CC value can indicate that something other than rain is present, like leaves, hail, branches, pieces of houses. This is a CC map. The red colors mean that everything is similar in the atmosphere, but the deeper in tone the colors get, the more dissimilar it is to other things in the atmosphere. As you can see there's a bunch of rain. Down here, you can see there's obviously a debris signature from a tornado. Using these different radar products together gives meteorologists a much clearer picture of what's happening in a storm. Now you, too, can understand what you're seeing when you open that weather app. From the radio signals in the sky, to the ones and zeros, to the colorful blobs on your phone, radar is a crucial tool from understanding weather. Who knows, having this knowledge could just save your life one day. Thanks for watching, and as always, have a great day.